Hello, good evening, everyone. Please confirm once that you can see me and you can hear me as well as you can see the slides. Please confirm once that you can see me, you can hear me as well as you can see the slides. Okay. Okay, thank you. We shall just start in 1 minute. A lot of students are joining, leaving. That is why I am just waiting. We'll just start in 1 minute. Okay, we shall start. So, very good afternoon, very good evening, everyone. My name is Ambuj. I am the scholar at Agriculture and Food Engineering Department from IIT Kharagpur. And what we'll be doing, we'll be solving some of the questions based on the previous week's content in front of you all. Okay, I'll try to give the explanation and you just try to solve these questions and answer using the chat box. Okay, and after these 10 questions based on the previous week's content are over, then afterwards we'll be going through some Google Colab notebooks which I have prepared to explain the concepts programmatically. Okay, that is the agenda for this particular meeting. Okay, we shall proceed. Yes, so very first question for the present session, I'll just put in front of you. Do try to answer this particular question. If we have a sample size of 20 and population standard deviation is known, what you will use? T-test for hypothesis testing, Z-test for hypothesis testing, both T and Z-test, or is it F-test? To try to solve, give the answer in the chat box. Okay, people are saying B, then some are saying A also. Good. T-test for hypothesis testing. Option B is option A. Okay. Due to my exams, I missed previous live session. Please upload it in YT cell. Yes, sir, it is uploaded. And I have given the link also just below your comment. Please go through it. Okay. Link along with the meeting notes, everything has been shared in this particular Google doc link. Okay, so go through it. Okay, so mixed response of A and B. Good. So you are saying some people are saying A, some people are saying B. So it's a mixed response of A and B. That's what you want to say. Okay. Actually, it will be B only. Okay. Red test for hypothesis testing. Why? Let us go through it. When you are deciding between a Z test and T test, only both options would be valid here. F test we will see later on. Okay. If you are deciding between a Z test, T test, two important factors are there. Is your population standard deviation known, or and what is your sample size? Okay. Both of these things are very, very important. Okay. So is the population standard deviation known, and what is the sample size? Okay. These two things are very, very important. Just 1 second. Yeah. If your population standard deviation is known, you will use the Z test regardless of the sample size. And if your population standard deviation sigma is unknown, then we will use t-test, especially for these small samples. Okay. Since the sample size has been given as small and equal to 20, okay, it means 20 is the sample size. Population standard deviation is known to you. Population standard deviation is known to me, okay, known to each and everyone. Then, in those particular cases, what you will use? Sigma is known, okay, we'll use Z test. Even though the sample size is less than 30, 20, or it may be anything, but do try to remember if your population standard deviation is known, then you have to use a Z test. Okay. T test is used when sigma is unknown. Both will be incorrect. Okay. You have to choose only one option. Okay. And F test is used to compare the variances, not means. Okay, we'll see about F test in our week 3 and in our week 4 and week 5 in detail. Okay, we'll solve some numerical questions for grammatical errors. So, what is the thing? So, correct option would be Z test for hypothesis testing. Okay, option B will be correct. Okay, not option A. Let us move forward. You have been given a null hypothesis. H0 mu1 minus mu2 equal to 0. Whether it is a upper tail test, lower tail test, two tail test, or whether it is a F test. Who try to answer this particular problem? Z test is used for large samples. Yes, generally it is used for large samples, but your population standard deviation is known. Okay. Since your population standard deviation is known, then we will use Z test here also. Yes, in general it is true. In general, whatever statement you mentioned, that is true. Yeah. When the null hypothesis says mu1 minus mu2 equal to 0, we are testing the whether the means are different in either directions, whatever two test. Okay, good. We'll see later on. If any doubt is there regarding Z test, please let me know. Or there is a doubt in the previous question, please let me know. Okay. Since the population standard deviation is known to me, I'll apply Z test here alone. Okay. I will not go to T test. If population standard deviation is unknown, okay, then in that particular case, I will use a T test. That is the term which I just mentioned. Okay. Yes, for large samples, definitely we will go for Z test. Okay, invariably. But in all those particular cases, population standard deviation should be known to me. That is the thing. H0 mu1 minus mu2 equal to 0 means there is no difference between two means. So we check both the sides, greater or smaller. So it is a two-field test. Okay, good. Okay, good. Before the session is there, okay, you must be getting some mails regarding your week's content. Okay, so try to go through those previous week's content before attending the session. That would be very, very helpful for you in order to solve these questions, in order to solve the assignments and submit them correct on correct time. Okay, so that will be very, very helpful for you guys. So that is why my sincere advice to you is do attend the offline content or recorded content that we are already providing to you. Okay. And before the we complete that, try to complete the assignment and whatever doubts are there, do keep them, do note and do make a note of them and ask in this particular sessions. Two sessions are being held, one is on Sunday, another one is on Tuesday. Okay. Try to get the maximum benefit. That is my sincere request. Okay. Yes. So regarding this question, it would be a two-tailed test. Since two students have mentioned it very correctly, your explanation is very correct. Okay. Null hypothesis has been given to you as mu1 minus mu2 equal to 0. Okay. Mu1 minus mu2 equal to 0. That is the null hypothesis. This in general states that there is no difference between the two population means. Okay. So why is it implying a two-tailed test? Because your null hypothesis is specifying in particular equality, that is equal to sign is present. Your alternative hypothesis would be mu1 minus mu2 not equal to 0. Okay. Whether it will be greater than 0, whether it will be less than 0. So we have to check in both the directions. It will make it a two-tailed test. If it is a upper tail test, in that particular case, your hypothesis, alternate hypothesis would have been mu1 minus mu2 greater than 0. If it is a lower tail test, then in that particular case, your alternate hypothesis would have been mu1 minus mu2 less than 0. And F test is used to compare variances very particularly. We have seen in previous question also, okay, not in particular means. So that is entirely ruled out. It will be two-tail test. Okay. As two students have mentioned and their explanation is written. Okay. So this is the thing. Keeping the spirit up, let us move forward. Okay. The quality control manager at a lithium battery factory needs to determine what he needs to determine. He needs to determine whether the mean life of a large shipment of a lithium battery is equal to the specified value of 375 hours. Process standard deviation is known to be 100 hours. The random sample of 64 batteries indicate that a sample mean life of 350 hours. Okay. State the null and alternate hypothesis. Okay. And here you just ignore this and you take it as mu. Okay. Mu that in this one. Okay. And just write it down mu. Mu equal to 375. Similarly, you try to keep a track in all of the questions. Okay. So you take it as mu equal to 375, mu less than equal to 375, mu equal to 350, mu greater than equal to 350. Null and alternate hypothesis. Okay. So you try to try to take any of those. Okay. The opposite of null hypothesis will become alternate hypothesis. If your null hypothesis is mu equal to 375, alternative is mu not equal to 375. So here two particular options have not been given in a single option. So you try to solve, okay, state only one, either null or either your alternate. Here they are checking whether the mean life is equal to 375. So the null hypothesis always contains equality. Okay, therefore its zero will be mu equal to 375. Okay, we will see. Others do try to present your opinions. As the question says to test whether average life equals to 375. Yeah, this one I have read. People are saying A. Okay, so equal to 375. Okay, no recipients are saying it. Okay, no problem. A. Good. For the maximum benefit of the students, I am requesting you all that I am allowing you to, even in the session, even if the 5 minutes are left. Okay. At 7:55 also, I allow you to join the meeting, but your benefit is maximum when you join the session at its scheduled time, that is 6 p.m. Okay. And do try to maintain your internet connectivity, okay, so that it doesn't get disrupted in between because students leave, then join, then again leave and join. Okay. I am allowing since it's an online class, okay, but your benefit will be maximum only if and only if you will join it on time, so that you will be able to keep the entire content, okay, whatever I have planned. Where can I get the recorded videos of previous such weeks? I have provided the link. I will provide it once again. Okay. You can get all the links there. Okay. Yes. Now you try to see here. It would be mu equal to 375 only. Why so? Let us see. This is hypo link is not working, sir. No, your internet connectivity must be somewhat different or somewhat disrupted. See here, I am clicking on the link. It is working perfectly fine. See here, my name is Ambuj. There you can find the presentation folder link, and you will find the YouTube links. So, Sanchita, your link, this link is working perfectly fine. Please try to see with your internet connectivity. That is the thing. Yeah. This is a hypothesis testing problem. Okay. Or population mean. Your manager wants to determine whether the mean life is equal to 375 hours. Okay. First of all, you have to identify the claim. The claim is saying that determine whether the mean life is equal to 375 hours. When we test a population mean for a specified value, equality goes into null hypothesis. So you state the hypothesis, which is null hypothesis, that is H0, that is mu equal to 375. Alternate H1 is mu not equal to 375. It's a two-tailed test because we are checking for equality in both the directions. Mu equal to 375 would be your null hypothesis, and mu not equal to 375 will be your alternate hypothesis. If an option is mu not equal to 375, then you have to go for both the options. Okay. There are two types of problems in the examination. Okay. Yeah. There are two types of problems on the examination. First one is MCQ, multiple choice question with a single correct choice. Okay. There is another type of problem which is MSQ. MSQ means multiple select question. So your multiple select question would be that in which more than one option would be correct, and you have to mark both the options. So even in GATE also, these type of problems are very, very common, more than one choice type of problems. So you have to be very, very careful. Read the question first, then mark the option. Whether it is an MCQ, whether it is an MSQ. Okay, both the things have to be confirmed. Then only you just try to uh, mark your option. Okay. So if mu equal to 375 is there, this option is correct. But if another option is there, which is suppose E has mu not equal to 375. Okay. This option will also be correct. This is the this option will be 100% error. Okay. This you try to keep a note of it in your mind. Okay. Yes. Let's move forward. In your question number three, at the alpha equal to 0.05. That is the level of significance. Is there any evidence that the mean is different from 375 hours? So in that this particular case, you have to uh, test for you have to go for a test statistic. You have to calculate, then compare with the standard table, and then you have to say that whether it is the difference exists or there is no difference or none of the above. Whatever the thing is, you just have to deal with this. 5% level, the calculated Z value is -2. Good. This is greater than critical value 1.96. Good. In absolute form, so we will reject the null hypothesis. Therefore, yes, there is evidence that the mean value is different from 179. Good. A. Good. Yes. The correct option would be yes, there is, as many of you have pointed out. Yes. Why? We will just see. Your null hypothesis is mu equal to 375. We formulated in our previous question only, and your alternate hypothesis is mu not equal to 375. Okay. Sigma is 100. That is known. That is given in the problem. Not given in the problem. Let me see. Here it is given that the process standard deviation is known to be 100. So it's okay. So sigma is 100. That is given to you. N is 64. So here in our previous question, random sample of 64 batteries indicates, okay, and a sample mean life of 350 hours. So your N will be 64 and your X bar, okay, that would be 350. Level of significance alpha is given as 0.05. Now you try to compute the standard error sigma over under root n, 100 over under root 64. 100 root 64 is 8. 100 over 8 is 12. Okay. You try to compute the test statistic, which is Z. Z is nothing but x bar minus mu 0 divided by SE. SE is standard error. So x bar is 350, mu 0 is 375. Okay. X bar minus mu divided by standard error, sigma over root n, that is 12.5. Now it is coming as minus 2. If you look at the detail, then at a level of significance 0.05, your critical value of Z would be plus minus 1.96. Now, how to make the statement? Since the value of the test statistic, okay, that is greater than the critical value, you will reject the null hypothesis and you will say that the alternate hypothesis is okay. You will reject the null hypothesis, you will say that alternate hypothesis H1 is correct. Okay. So you will say that there exists a sufficient difference at 5% level of significance that mean life is different from 375. Okay, that is the thing. Okay. If you have any doubt, after the class is over, I'll upload the PDF, I'll upload the notes, go through them, okay, analyze each and everything critically, and then say what is the correct option. Okay. Now we will move forward. Tell step 3 and 4. Okay, I'll repeat step number 3 and 4. Okay. First of all, we have computed the test statistic. Z test statistic as x bar minus mu 0 divided by standard error, that is sigma over under root n. Okay, that test statistic we have calculated as minus 2. This entire thing we have determined from the standard Z table. We try to search it down. Okay, there you will find the level of significance alpha is 0.05. Okay. For alpha equal to 0.05, your critical value of Z will be coming as plus minus 1.96. Okay. And for the examination, that critical value will be given to you. Okay. Here it is not given, but I am very sure either you will be provided a Z table or you will be given the value. Okay. So the critical value of Z is coming. This is coming from Z table. Okay. Standard Z table, T table, and all the tables from test statistics, F table, P table, everything is there. Okay. This is coming from a standard table. You just try to Google it down or you or in the next examination, in the next class to remind me, I'll upload the PDF of Z. Or in this session only, after the class is over, I'll upload the Z table along with P table, T table, and F table. Okay. For level of significance alpha equal to 0.05, this value will come. Okay, plus minus 1.966. I'll upload the table, then you try to go through the table. You will find it very easily. Okay. And for the examination, the critical value will be provided to you. Otherwise, you cannot solve the question. Okay. Because you don't have to remember. Okay. After that, the main point is that if the mod value of Z, okay, it would be greater than the critical value or it would be less than critical value. If it is greater than critical value, then you have to reject the alternate hypothesis or accept the you have to reject the null hypothesis or accept the alternate hypothesis. Okay. And if your Z critical Z value, okay, which you have calculated, Z test statistic, okay, that particular value is less than your critical value. In that particular case, you have to accept the null hypothesis or reject the alternate hypothesis. Okay. So here what I am saying that you compute the Z test statistic. Okay. If your Z test, okay, that particular value, you take the modulus, okay, take the magnitude only, forget about the sign. It is coming greater than Z critical. Okay. Since it is greater than Z critical, I am rejecting the null hypothesis or I am accepting the alternate hypothesis. Okay. So yes, if you are rejecting the null hypothesis, what was the null hypothesis? Null hypothesis was mu equal to 375. Okay. So you are rejecting means you are accepting the null hypothesis, alternate hypothesis, that is mu not equal to 375. That is why the conclusion is this, that there is this a significant, a sufficient difference at 5% significance level, that the mean life is different from 375 couples. Okay. This, you don't worry about the critical value. I'll provide the Z table, T table, P table, all the tables in this link which I have provided to you. Okay. Thereby, you can just go for the level of significance. It will directly give you the value of Z critical. You don't have to remember it. Neither there exists a formula for it. Okay. That value, that entire table, along with log table, cost table, sine table, every other table, there is a particular table book. Okay, that is given to the students in the examination. That is the pattern. Okay. Or another thing is that the value directly is provided in the examination. It would be written that Z critical value is 1 plus minus 1.96. So don't worry about it. Okay. Okay. Let us go through the another question. For one tail test, the test statistic Z is determined to be 0. The p-value for this test is 0, minus 0.5, plus 0.5, or 1. This is the next question. Okay, I hope the fourth question is clear to you all. Okay, any doubt is there, feel free to ask. I'll explain once again also. Is when the test statistic Z equals to 0, half of the normal distribution lies on the one side, but in one tail test, the p-value would be 0.5. Good. Other students also try to give your opinions. How much percentage of assignment questions can we can expect in the paper? Lot percentage of assignment questions you can expect in the paper. Whatever questions will be coming in the examination, they will be based on this content. Okay, based on the assignment and the content which I am giving to you. Okay, they will be based, not entirely. They will be from this. But if you are in a position to solve these questions and your concepts are clear, then very easily you will be able to solve the questions which will come in the examination. Okay. That is the answer to your question. Yes, I have answered this question already. The correct option would be 0.5 only. Okay, 0.5 as all of you have answered. You have been given a one-tail test. The test statistic is z equal to 0. For one-tail test, test statistic is to be determined as to be 0. Already it has been determined as 0. What is the p-value that is being asked? You need to understand if what is z equal to 0 means. Z equal to 0 means the sample mean is exactly equal to the population mean. Okay. So in your standard normal distribution, area to the right of 0 is 0.5 and to the left of 0 is 0. So area to the left will be also 0.5, area to the right will also be also 0.5. Okay, it's a one-tail test. Okay, so right tail right tail test, the p-value will be 0.5, left tail test, p-value will be 0.5. Either the way, probability will be 0.5. Okay, you have to determine what is the p-value for this test. Okay, so probability that p-value would be 0.5 only. Okay, since the sample mean is exactly equal to the population mean. Okay, hypothesized population mean, it will be exactly lying into the center. Z equal to 0 will be exactly lying into the center. And now you will see that area to the left and area to the right will be equal, and that will be exactly equal to 0.5. Okay. So 0 is incorrect, minus 0.5, probability cannot be negative, and 1. No, it will represent the total probability. Both of the options would be, all of the options would be incorrect. The correct option would be one only, would be one. Okay, that is C. C 0.5. Okay, that is the thing. Now you try to see this particular problem. The error of rejecting a true null hypothesis is 0. Okay. The error of rejecting a true null hypothesis is 0. Okay. Whether it's a type 1 error, whether it's a type 2 error, whether it is same as B, okay, or committed when not enough information is available. Okay. So you try to solve, you try to give your opinion. Yes, indeed. Now you try to see here. It would be type 1 error only. Okay, type 1 error. Most of the students, I think, they are able to identify it correctly. Yes. When we reject a null hypothesis, you want to say when we reject a null hypothesis, that is actually true. So type 1 error, yes. The null is false connected. Good, very good. Yes, indeed, it will be a type 1 error. Why? Because in your hypothesis testing, there are two fundamental types of errors. Okay. First one is type 1 error, another one is type 2 error. Type 1 error, it will exist when you are rejecting a two null hypothesis. Okay. Just 1 second. A student wants to join the call. Mm, Um, okay, no problem. Yeah. In your hypothesis testing, there are two fundamental types of errors, type 1 error, type 2 error. Type 1 error exists when you are rejecting a two null hypothesis. If you are rejecting H0 and H0 is actually true. Okay. So there is exists a type 1 error. Probability of committing a type 1 error is denoted by the alpha, which is the level of significance that we have seen in the previous question is 5%. Okay. Type 2 error means it occurs when we are failing to reject a false null hypothesis. And this particular error is denoted by beta. So type 1 error is correct, type 2 error is not correct, same as B is incorrect, and committed when not enough information is available. No. This option will also be incorrect. Why? Because errors are defined by decision outputs, not by the information content. So it would be a type 1 error. So try to keep a note of it in the examination. Okay. Now we try to see this particular problem. The mean cost of a hotel room in a city is said to be $168 per night. Random sample of 25 hotels resulted in a X bar, which is 172.50, and sample standard deviation is 15.40. What is T statistic? The T statistic value you have to calculate whether it will be 2, whether it will be -2, whether it will be 1.6, or it would be minus 1.6. This will try to calculate. Okay. Mean cost of a hotel room in a city is said to be $168 per night. Random sample of 25 hotels rated in X bar equal to 172.50. Sample standard deviation is equal to 15.40. Calculate the T statistic. This is the problem. 1.46. Okay. Yeah. 1.46 is the call. Okay. Good. 1.46, 1.46. Okay. Okay, so mean cost is 168, sample of 25 bottles, mean 172.50, standard deviation 13.40, peak formula you have applied, then you have said 1.46. Good, very good. Okay. We'll see. It is indeed 1.46. Okay, we'll solve. First of all, you have to see what the data has been given to you. Mean cost of a hotel room in a city is said to be 168 per night. Random sample 25 hotels. Related max bar of 172.50. Sample standard deviation is 15.40. Each statistic we will try to calculate, which is x bar minus mu divided by standard error, that is s over root r. X bar has been given to us 172.50. Mu has been given as 168. S is 15.40. Okay, 15.40. Standard deviation S has been provided to us. N is 25 because sample size is 25. Okay, you calculate S over under root n, 15.40 divided by under root 25, that is 3.08. Then you try to calculate the t test value, which is 172.50 minus 168 divided by 3.08. It will come 1.46. So here you were asked to calculate t test or t statistic. So directly you have applied the formula and you have calculated the value and found out it to be 1.46. Okay. When a student is having any doubt, feel free to ask. Okay. Next we'll move on to the next question. Eighth question is this one is hypothesis testing. If the null hypothesis is rejected, then no conclusions can be drawn from the test. Alternate hypothesis is true. Data must have been accumulated incorrectly or the sample size has been too small. This is the question. Okay. Try to solve. You try to give your opinions in hypothesis testing. If the null hypothesis is rejected, no conclusions can be drawn from the test. An alternate hypothesis is true. Data must be accumulated incorrectly must have been accumulated incorrectly and the sample size has been too small. Okay. Yes. So please show the last solution. I'll repeat once again. Okay. Most of the students are saying B. If the null hypothesis is rejected in hypothesis testing, it means that there is sufficient statistical evidence to support an alternative hypothesis and which open rule of significance. Therefore, among the given options, the correct option is and the alternate hypothesis accepted is more likely to be true based on the sample data. Okay, good. The alternate hypothesis is true. Okay, in hypothesis testing, if the null hypothesis is rejected, that means the alternate hypothesis is true. Okay. No conclusions can be drawn from the test. No. And data must have been accumulated incorrectly. No. These two options are nothing. They are bogus. Directly you can eliminate from seeing it in the first hand also only. Okay. The sample size has been too small. No. For the sample size to be too small also, there exists the test statistic, everything exists. Okay. So never say like this. Okay. So C option and A option they are not correct. D option has got no meaning. B option will be correct. So, you are conducting hypothesis testing. This is a decision rule. Your evidence is sufficient. Then you fail to reject the null hypothesis. If evidence is sufficient, then you reject the null hypothesis. If you are rejecting the null hypothesis, you are accepting the alternate hypothesis. Okay. So data were incorrect and sample size was too small, no confusion can be drawn. This all are incorrect. Your meaning is this that the result is statistically significant and will support the alternate hypothesis. So alternate hypothesis is true. This is the correct option. Okay. Next question. We try to see here in the hypothesis testing procedure, alpha is 1 minus the level of significance, the critical value, the confidence value, or the level of significance. By this particular time in the lecture, each and every student should be very confident about this particular question. I want maximum of you to answer. Okay, what is it? I have repeated multiple times within this lecture only. Okay, so please do try to tell me. That is D. Alpha means the level of significance. Okay, D. Good. At least a lot of students are answering. Good. Indeed, the correct option would be level of significance only. Okay. Why so? In your hypothesis testing, your alpha will be representing the probability of committing type 1 error. It will mean the probability of rejecting a true null hypothesis. By definition, your alpha will be level of significance. It is the threshold which is used to decide whether the test statistic falls in the rejection region. So 1 minus level of significance is incorrect, and the critical value that is also incorrect, and the confidence level that is also incorrect, and the confidence level 1 minus alpha that is also incorrect. So correct option would be level of significance. By the end of this particular session, you should at least even appreciate that this is the correct option. So it would be level of significance. Okay. So is this lecture accessible later and can we access it? Yes, you can access it. I'll just give you the link. Meanwhile, let us move to the last question of the 10 questions which I wanted to discuss with you all guys. If a hypothesis is rejected at the 5% level of significance, it will always be rejected at the 1% level. It will always be accepted at 1% level. It will never be tested at 1% level or maybe rejected or not rejected at 1% level. This you try to answer. Okay. And the person who was asking me that, sir, whether you would be able to access the lecture. Let me give you the link. Also, going to discuss this first, and then give you the link. Yeah. Let me pin this also. One second. Messages. Let me pin this. Okay. I have given it for you all. Okay. And print also. Yeah. I think now you can see the slides. Okay. And if any issue is there, anytime do comment. Okay. Whether slides are not visible or whether any miscommunication with the echo is there, any problem with video, audio, and presentation, you just try to tell in the messages. Okay. Let me admit. See, you can join in at any particular time, but my sincere advice to you all is that join the session at its scheduled time, that is 6 to 8. Okay. You can even I am allowing you just 5 minutes before the end of the session at 7:55 also I'm allowing, but it will not create any further impact. Okay. It will not create benefit to you. That is why I am saying that to join the session at the start. Okay. That will take you to the maximum benefit. Okay. You are saying it good. Now you try to see here. Let me go through what options you have given. Question mark slash. What you want to convey D A D, then a mixed response. See here, it may be rejected or not rejected at 1% level of significance. Okay. Why you are saying that it will always be rejected, it will always be accepted? No, it will never be tested. What is the meaning? No, there is no meaning to it. It may be rejected, it may not be rejected. That we have to confirm with the test statistic table. Okay. Directly we will perform the test. After performing the test, we will go through the standard table. And if the standard table allows us that whether the value is greater or less than the test statistic which we have calculated, z test, p test, t test, f test, that test statistic we have calculated, and we will compare it with the standard table whether it would be less than or greater than that only will give us the idea whether the hypothesis may has to be rejected or accepted. Okay, at 1% level of significance. Okay, that is the explanation. Your hypothesis is rejected at 5% level of significance. It will mean that your p-value is less than 0.05. At 1% level of significance, okay, it is more stringent because 0.001 is less than 0.05. So rejection at 5% will only test that it is below 0.05. It might be between 0.01 and 0.05. Rejected at 5%, not rejected at 1%. Less than 0.01, rejected at both 1% and 5%. Rejection at 5% will not guarantee rejection at 1%. Okay. So these options will never, they are seldom true. Okay. They are often false. Okay. So will always be rejected, will always be accepted, will never be tested, will never be tested, then we are not working in the field of statistics. We are working in some another field, which I also failed to convey. Okay. So these three options would be incorrect. May be rejected, not rejected at 1% level, that is 100% correct. So this is marks the end of the 10 questions which I wanted to discuss with you all guys. Okay. So, if you are having any doubt, feel free to ask. Tanu, I think that you must have understood that why we are rejecting it or we are not rejecting it at 1% level of significance. Okay. So, please be thorough with it. Okay. Still had doubt on it, sir. Please feel free to ask. Use the chat box, try to answer. You can unmute yourself also. Let me give the option of turning on the microphone. Okay, you can ask. Give a green signal, that is when we can move forward. Okay. Anybody, any doubts? Anything? Anything? What doubt are you having? Feel free to write. Thereby I can hear itself convey to you. Okay. I don't think so. But still any doubt is there. If any doubt is there, feel free to ask. Okay. Let us move forward because the time of the session is limited. Okay. So, in this particular session, I have given to you, told you about what is test statistic, how we are dealing with test statistics, and how we are performing the test statistics, how we are comparing with the standard tables, and whether we are implying which option is correct, which option is not correct. Okay, that we have done. Okay, now we will do the same exercise programmatically. Okay. So you should be well aware since you most of you would be CSE students. Okay, so you should be well aware, okay, about the options, about the things. Okay. So first of all, let me introduce to you about a new library which is pandas. And one more reminder from my side that after the session is over, okay, do download these particular notebooks. They are given in your .py format, .ipynib format, both the formats. I'll provide you a notebook and try to run yourself in the Colab platform. You will just have to Google search Colab, then you have to, yeah, then you have to go for open Colab and then here upload. Okay. From the upload option, you just have to give paths to the notebooks where you have to download, where you have downloaded. And don't ask me for the access, okay, because I will not allow you to have the access of these notebooks. So thereby you will change each and everything. Okay, so I cannot allow you that. We cannot work on the same notebook. Okay, that is the restriction because each and every student, if he will just change the original source code, then it would be entirely different source code at the end. Okay, where you will get the code in the pinned comment. Okay, you will get the code, you will get the PDF, you will get the recording in the pinned comment. It is the thing. Introduction to pandas. Okay, from pandas is a particular library. You are importing series and data frame. Okay, pandas is imported as PD, numpy is imported as NP. You can change both of these. You can import pandas as NP and import numpy as PD. Nothing will happen, but you have to write the syntax accordingly. Now we created an object which is a series 4, 7, minus 5 and 3. And now you have printed object. Okay, we will try to run this particular cell one by one. We will try to run all the cells one by one and try to manipulate some of the options. Okay, thereby you will get better idea. Okay, first cell is run successfully, then second cell I have run successfully. I have created an object which is a series. Okay, 4, 7, minus 5 and 3. Okay, then you try to see this object we have tried it to print. So it is created as an object. Values we have stored at 4, 7, minus 5 and 3. Indexing always in Python starts from 0. This is the indexing 0, 1, 2 and 3. Okay. Now what are the values? What values are in form of an array which is 4, 7, minus 5 and 3 that we have tried to print. OBG means object dot values. Then object set index that also you can try to print. Okay, that would be starting at 0, stopping at 4, and this step is 0 to 4, starting and stopping index, and step is 1. Okay, object 2, object 1, OBG that I have declared. The second object I will try to make, which is series 4, 7, minus 5, 3, and indexing I have changed it DBCA. Okay, so this cell is empty. Then OBG2 object, second object, I try to print out. Here you try to see values it has stored currently 4, 7, minus 5 and 3. And the indexing it has put as DBCA in itself. Okay, DBCA. So that is the indexing. Now you try to print the indexing. Index values it has printed as DBCA and data type as it has printed successfully as object. Now you try to see object 2 as ACB. ACB values means the index values which are there stored as A, C, and B. What were the values which we have stored as A, C, and B? They were 3, minus 5, and 7. So 3, minus, and 5, and 7, these values directly it is printed. Okay. Then object 2 multiplied by 2 means every value of this particular object will be multiplied by 2. So 3 2s is no, DBCA. DBCA 4, 7, minus 5, 3. The values would be 8, 14, minus 10, and 6. 8, 14, minus 10, and 6 for the values. Okay. Then NP dot EXP. NP is numpy dot exponential of object 2. Okay. So object 2 directly the values as an exponential e to the power exponential we have calculated. Okay. So e to the power x, that is the denomination here. E is 2.71, 2.751 to the power 8. It will be coming as 54.5. Okay. Let me go through the calculator, show you the calculation also, thereby you will get a better. Just 1 second. Okay. So directly we have computed the exponential of objective values. So objective values we have just tried to calculate. So 1 second. See here, you're able to see my screen or not. See here, calculator, I think it is visible to you. You can see here. Yeah. So directly see here object two values. Okay. Where was object 2 declared? Object 2 was declared as 47 minus 5 and 3. Indexing we have calculated. And here one manipulation object 2 into 2 directly we have printed the value. Okay, that is the manipulation we have done. But we have not changed the individual values of the object 2. Okay. And here we are trying to perform the calculation np.exp object 2 means exponential of object 2. Okay. So you just try to run this cell, it is coming the same. You just try to run this particular cell, it would be nothing but I will be doing this calculation 4, 7, 8 minus 5 and 3. Okay. So here is from the scientific calculator, I will do the calculation 4 and then here is the exponential function that you try to calculate. You are getting this particular value 54.5. This is 54.5. Okay. So similar exercise you can do for other values also. Okay. 4, then 7. That value try to compute 1096.66633. Then minus 5 also I will demonstrate. Okay, no problem. That is 0.06737. Okay. Exponential minus 5 we have demonstrated. Then exponential of last value was 3. So last value was 3. We will try to write it down. 3, 20.08. Okay. So np dot exponential objective we have calculated. Then whether this particular e exponential is there in object 2? No, it is false. Whether d is in object 2? Yes, it is true. Yeah. Indexing it was, I accidentally told you exponential. No, it is indexing. In single quotes, if we have written e in object 2, we are checking the condition whether the indexing e is there in object 2 array or not. It is the statement is returning false. And if I write in single quotes whether d index is there in object 2 or not, it is returning me as true. Okay. Then as data, Ohio, Texas, Oregon, and Utah. Okay. Directly as a array with the index I have given to you. And created this object 3 with this particular series. And there I have printed the object 3 array. So it will give me Ohio mapped with 35,000, Texas with 71,000, Oregon with 16,000, Utah with 5,000. These values already I have provided. Okay. Then another thing, states I have declared California, Ohio, Oregon, and Texas. Then object 4 I have created as a series with this particular state names. And then object 4 we have tried to print. Okay. And then we have tried to calculate whether object 4 is null or not. Okay. whether it is a void or whether it is not a void. So whether it is null, no. It is California. It is true. It's not is null because it is not mapped with any particular value. Okay. We have not mapped. That is why it is returning as null. Ohio, Oregon, and Texas we have mapped with a value. That is why for all these categories it is will return false. Important for your output type questions. So not null means opposite of null. Okay, is null means you are checking the condition which one is null. Not null means opposite to these conditions you will get the answer. So California will be false and Ohio, Oregon, Texas would be true. This one I ran and this one I will run. Yeah. Then you try to see object 3 we have printed Ohio, Texas, Oregon, Utah. Object 4 we have tried to print that California. It is not mapped to any value. That is why it is returning here name, not number. Okay. Then object 3 plus object 4, California, Ohio, Oregon, Texas, Utah. Okay. So it will be sum of all the values. Okay. Sum of both the arrays, it will print. Okay. That is the thing. Object 3 plus object 4. Values individually it has added as well as uh, values already it has added. Okay. As well as the combination of arrays there. Just 1 second. Whenever I allow the facility of muting, unmuting, then some disruption is there. Some ho ho and hush hush is there. I don't know about that. Screen is, I think, visible to go on. Yeah, no problem. Yeah. Object 3, object 4, then we have sum, and then we have seen the values. Then object 4 dot name equal to population. Okay. Object 4 dot index name, that is the state, and object 4 value we have tried to print. Okay. An object we are trying to see what is stored as in the object series. Okay. An object index, we are saying it as Bob, Steve, Ram, and Ryan. Directly we have given the new. Okay. Then data as a data frame we have prepared state this particular values, year this particular values, population this particular values. Then we have created a data frame from this particular data array. Okay. And frame we are trying to print that is giving the same values which we have tried to incorporate. Okay. Then comes your data frame. Okay, data frame we have tried to print. Then frame 2 from a data frame we have just circumvented some of the values. Then frame 2 we have tried to just manipulate once again. Okay. Then frame 2 dot columns. Yes, these are the columns. It will give you directly the access to the columns. Then if you want to see the values of a certain column, you have to give it in the index. Okay. That like I want to see the state, then I have given the state as the index. Okay. Then frame 2 dot year. Yes, if I want to see the year parity, I will write it here as year. And if you want to compare the condition, in which of the cases depth is equal to 16.5, you want to see those columns. First of all, you will get the condition. After that, you will try to print the frame. Okay. So stepwise, step manner, you try to execute. Then frame 2 depth equal to np dot arrange 5 dot. Okay. Means what are the values which are starting with 5? Okay. It will be arranged. Okay. This is the thing. Then a particular value from this series we have tried to incorporate, and then same manipulation, frame to depth equal to val. Okay, you have tried to compare the condition and then try to print the frame. Okay. And similar thing with another condition in the state condition equal to Ohio. Means we are trying to compare the condition. Okay, equal to Ohio. We have used. checking the condition. Then delete frame to string ESPEL is in short for deletion. In columns we have tried to print. Okay. And similar exercise for the series, it is written here. What are the values? What are the indexing? Already I have told to you multiple times. Object 1, 2, and 3 I have tried to declare, then I have tried to tell you. Okay. Then object 2, object A, then multiplication 2, then exponential. Then if R is there in object 2, no R is not there, that is why it is false. Then is data. Okay. Z3, the mistake. Same exercise is there. That is why I'm not explaining much. Okay. Same thing, same everything I have tried to do with object 3, object 4, object similar multiple objects we can create. But you have to understand what is a data frame, what data frame, how data frame is created, and how you can compare the conditions between one frame, between two frames, how you can perform the manipulation. Okay. That is step by step manner I am trying to show here. If you are having any problem, that you will only have when you will try to run the notebooks. Okay. Just looking here won't give you the idea. You have to practice coding yourself, and thereby you will get stuck somewhere. Then you will go through the notes once again, and thereby you will realize that what mistake you have come. Okay. This is the manner in which you have to proceed. Okay. Yes. Then you try to see np dot array I have used. Okay. So creating an array. Okay. Then columns we have tried to print. State we have tried to label. Here we have tried to label. Then get equal to 16.5 we are trying to compare. Same thing is there. I'm just running it once again. Okay. This marks the end of this particular notebook. Next notebook is regarding missing value imputation. Missing value imputation means, first of all, you try to understand what is imputation. Imputation in general, what is it means that, see, so for example, a series is there 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. These are the 10 values of a series. Okay. So in this 10 values, suppose if I will say like this 1, 2, 3, 4, 5, and in place of 6, there is a blank. Then 7 is there, 8 is there. Then in place of 9, there is a blank. And then it is 10. I'll write it down in the message here. Okay. Suppose there are series 1, 2, 3, 4, 5. Okay. And there is a blank afterwards. Okay. Then 6, then 7 is there. Then 8 is there. Then again a blank is there. Okay. And then afterwards 10 is there. So what will come in these two particular blanks? Very easily you will be able to tell that what will come 6 and 9, because there exists a pattern that you try to follow and you got the answer that, sir, here I am getting 6 and 9 in place of the dashes. Okay. So this is one example of imputation. Okay. This is one example of imputation. I am I am repeating it. What you mean by imputation? Imputation means just calculating the values of missing items in a series by judging the pattern, finding the pattern. Okay. That is the meaning of imputation. So if a simple series exists like in this particular case 1, 2, 3, 4, 5, and two blanks are there, and afterward one blank is there, then 7 and 8 are written, then one blank is there, then 10 is written. So very easily you will be able, in a position to tell that, sir, in place of first blank 6 will come, in place of second blank 9 will come. So how you are able to say, because there is only difference of one value and they are getting added. So you have just got the pattern. Okay, you have got the pattern, which pattern is existing, and then you are able to tell that what will come in place of the missing values. So in general, it is known as missing value imputation. Missing value imputation. Okay. So missing value computation, how you will perform? First of all, you have to build a relationship between the values. Okay. And you have to check what values are missing. First, then you try to build the relationship in the between the values, and then you try to tell that which value you are getting in place of the missing values. Okay. So you try to see here how we are performing it. First of all, we are importing NumPy, then we are importing a library sklearn, and simple imputer directly we have imputed this particular function will include the value. Okay, in for us. Okay, then we have imported sklearn.experimental, sklearn.impute. These all the libraries, standard libraries we have imported. We have just imported. Okay. Then with the help of an imputer, okay, simple imputer and strategy as a mean means in place of 1, 2, 3, 4, 5, 6, 7, two blanks. Okay, 7 and 5, mean of 7 and 5 will be uh, always 6. Mean of 10 and 8 will be coming 9. So strategy which I am implying for calculating the missing value or the imputed value is mean. Okay. So that I have tried to fit between 1, 2, 2, 3, and 7, 6. Okay. And then I have tried to print the imputed transform matrix. Okay. So it will be giving me n 2, then 6, NaN. NaN is not a number. Then 7, 6. Okay. So directly it has transformed into mean. Okay. Mean of all the imputed or values. It has tried to calculate as a mean and give us the answer. Okay. In place of simple imputer, you can also use iterative imputer. It will perform the iteration. Then you try to give the options. Okay. What is the imputed values or the missing values? So here I am using strategy as mode. Okay. Mode imputation. Import pandas as PD, then data frame I have created. Then I have imputed the in the simple imputer. I have given the strategy as most value. Okay. So directly it has replaced the missing values with this particular uh, most frequent or the mode of the observations. Mode of all the observations. So mode was here particular case in cases of your indexing, it is mostly replaced with y. In second index and in first index, it is replaced with a. Okay. Then iterative imputer. Okay, multivariate feature imputation is iterative. It will try to iteration for one particular iteration number and try to see that in which particular fashion it is in which particular iteration it is getting a particular number. Okay. So here I did a computer in this particular case I have given the maximum iterations as 10. Okay. And I try to put these particular values in this particular fashion. Okay. In this np dot nan and np dot nan it has tried to compute and give the transform matrix. Okay. We have tried to just okay. So it has replaced with 1 np.nan with 1, then 6.np.nan it has replaced with 12. Okay. The iteration, the value at which it will be striking. It will try to give that particular value. Okay. Then SLR, simple linear regression. Okay. NumPy is NP, then scalar linear model, importing linear regression. X and Y are declared as an array. Okay. Then X array we have just tried to print, then Y as an array we have tried to print. Model we have given for linear regression. Then fitting X and Y values. Okay. Let's say fitting X and Y in terms of linear regression, we have tried to print. We have tried to fit. Okay, fitting X and Y in your linear regression model and determining the coefficient of determination R square. It is coming as 0.7. Although it is not very accurate. The coefficient of determination for most of the machine learning models we it is acceptable if and only if it is more than 0.9. In very few cases in which none of the models is able to fit, we go for the value as 0.80. 0.80 value, and afterwards we try to take. Okay. In few of the cases only it is allowable. But most of the times we try to go with the values which are in the range of 0.90. 0.90 and the values which are greater than that. Okay. That is more encouraging for practical applications. Then you try to print the model intercept, then you try to print the slope, then you try to give the equation of predicted response, a prediction of all the x's. When y will be given to you, then what is the x values coming from the model. Then you can practice this particular exercise. You can try to predict y new with these x news. Try to fit a simple linear regression model. How you will do? X new equal to np dot in, then reshape in terms of -1 to 1 x new. Okay. Then y new is model dot predict x new, and y new try to predict. So it is the deviation is far more, okay, but still the values would be with the more the number of values, more the number of x and y values you will provide, and higher will be the coefficient of determination. Model error will decrease. Multiple linear regression also you can fit. X value is this particular one. X as an array, indexing of values. Okay. Couple of values we have provided. Y also we have provided. Then np dot array x and y. X value we have printed, then y value we have printed, then model equal to linear regression dot fit xy. Okay, we try to fit these particular values. Then R square of the model we have tried to print. Okay. Then coefficient of determination we are getting as 0.86. It is in general higher as compared to linear regression. In case of linear regression, it was 0.71. Okay. Now you try to see that what is the intercept. Intercept we are getting is 5.522. And what is the slope we are getting? Slope we are getting is 0.447 and 0.225. Sir, why two slopes are present? Because it is multiple linear regression. The coefficients would be y equal to alpha 1 plus beta 1 plus beta plus gamma 1 x1 plus similarly alpha 2 plus beta 2 plus gamma 2 in x2. That is why two different coefficients are there for slopes. Then predicted values of y, you can see what is the predicted response, and then there is an exercise or you all for printing the MLR using the multiple linear regression and printing the different x values. Then from sklearn, you have to import polynomial for polynomial regression. You just have to import this particular polynomial features from polynomial regression. Okay. These all the facilities are even available in Excel also. But for larger data, for big data analytics, if the rows and columns are 10,000, then your Excel software will not be able to give you the correct equation. For this particular process, you have to go for programming. And in programming, either you go for Python programming or the same facility you try to avail in your C language or C sharp. That is the limitation of Excel as well as Origin Pro. Both the softwares, they are able to not handle more than 1,000 rows. Okay. Some students always try to ask me, sir, same facilities are available in the Excel, why we have to write code? You have to write the code, you have to learn to write the code, because in case of your real time data processing, you will get large number of values in form of a CSV file. That CSV file will be containing 10,000 rows. And then that particular values, you try to, if you will try to impute or you will try to uh, perform the polynomial regression in Excel software or Origin software or in Excel solver or in any of the softwares, they will not be in a position to give you the correct questions. That is it. In that particular case, you have to go for programming, either Python programming or C programming. Okay, that is the thing. Here we are performing the polynomial regression using x and y as arrays. Two arrays we have declared. Then polynomial feature, polynomial with a degree 2, we have tried to fit, and bias we have not introduced, that is why I have written false. Here you can go for true, you can increase the number degree as up to 10, 12, 13, 14, 15 based on your convenience. Okay. Then you try to fit the transformer model. Okay. Then you try to print the x values. Okay. Then again coefficient of determination. Here I have printed with linear regression. What is the R square is coming? Okay, for the same thing, R square with linear regression is coming 0.71. Okay, with your multiple linear regression is coming as not printed. Okay, and with it, yeah, with the same particular values for MLR. What is the coefficient? What was the coefficient of determination? It was 0.8615. Okay, and for this particular transformer model or for polynomial regression, we will just try to see, yeah, fitted x. Okay, just 1 second. Okay, this is regarding OLS. I am looking for performing the same coefficient of determination analysis for your multiple linear regression. I have not included that. I'll just include here only. No problem. Okay, I will add it. Okay, thereby I will tell you that how for polynomial regression, what coefficient I was getting, what R square coefficient I was getting. I'll add a line to that. Thereby you will be in a position to compare linear regression with multiple linear regression and with your this polynomial regression. I'll add here. Okay. But here one another thing is there, advanced linear regression or ordinary least square regression is there, Wallace equation is there. For that we have declared the x, we have declared the y, we have created x and y. Okay. Then we have added the constant x here, then y is an array. And directly we have fitted this SM.OLS, ordinary least square regression. And after fitting, what we are getting the results here, you can see R square is coming 0.862. I think it is the highest. Okay. Because for multiple linear regression, it was 8.8615. So in comparison to that only we are getting, no problem. Okay. 0.862. 861 was the R square in case of your multiple linear regression. In case of your OLS regression, you are getting 0.862. Okay. Main thing is this particular table will give you a much better idea, skewness, kurtosis, as well as the JV matrix, probability, everything is mentioned here. Try to go through it. Okay. Then one more thing is there, that how you can just solve your these type of questions, p value, z value, t value using Python. Okay. For that, you have to import stats from SciPy library. Okay. Then you have to create the normal function. You have to provide the main value. Okay. Then you have to provide CDF. Okay, and then after it, the particular problem was is here. The mean response time of random 30 pizza deliveries is 32 minutes. Population standard deviation is believed to be 10 minutes. H0 is zero point 0 at alpha equal to zero point 0.05 level of significance. You have to determine whether the service goal 30 minutes or less will be achieved or not. Okay. So mu, sigma, n, x bar, and significance level alpha equal to 0.0. Directly Z we have computed. The same things which we have computed manually, I have computed with your Python. Okay. Then what I'm calculating, what is the normal value? Okay, some of you was asking me that, sir, what is how we are getting the Z critical value? That Z critical value we are trying to print. Okay, that P value uh, we are trying to print as well as the Z value directly we have computed. Okay. So P value is greater than alpha, so we are not rejecting the null hypothesis. There does not exist statistical significance to infer that the Z delivery is not meeting goal of 30 minutes. Okay. So directly that particular critical value we have printed Z alpha from this particular function. Stats.norm ppf 1 minus alpha, or in place of 1 minus alpha you can get a. If you are in a position, if you are given calculator or you are given table in the examination, fine. Otherwise, with Python also you can get the critical value, Z critical value. 1.86 for the in your question number 2 or question number 3. If that particular function is here, using that particular function, you can calculate that particular value also. Okay. Same example I have solved manually. Okay, in front of you all. That I have tried to solve with Python. If you are having any doubt, feel free to ask me. Okay. Otherwise, the session is over from my side. Okay. Here just I have to add one particular regression coefficient that I will do. Okay. And that afterwards I will give you these Python files. Go through each and every line, try to run the code yourself. Okay. And if you are not able to understand anything, then feel free to ask me. Yes, one question is there from James T. Sir, alpha values directly related to type 1 error. Yes, alpha values directly related to the errors. I think you are asking about this particular question. If a hypothesis is rejected at 5% level of significance, it may be rejected, may not be rejected. Your alpha value is related with your type 1 and type 2 errors. Okay. Why is it related? Because whether you are accepting the null hypothesis or you are rejecting the null hypothesis, or you are accepting the alternate hypothesis or you are rejecting the null alternate hypothesis, that only depends on the level of significance. Okay, it may be accepted at one particular level of significance, it may be rejected at one particular level of significance. Okay. So alpha value, yes, indeed, it is directly related to type 1 and type 2 errors. Okay. You are 100% correct. Okay. So this is the end. Okay, this marks the end of the 10 questions as well as the two collab notebooks which I wanted to discuss with you guys. Okay. After the session is over, I'll upload both of these notebooks. Okay. And then please go through it. And after going through it, if you have any doubt, feel free to ask me. Okay. Yes. Regarding question format, please contact the NPTEL team from there. And somebody was asking me how to contact the NPTEL team. See here, the mail which you must have seen here. Okay. You must have received. In this particular mail, there is a Google group created. Okay. In that particular Google group, there will be mention about the TAs. Okay. The TAs who are taking this particular course, they are designing the lecture handout and everything. So they will be in a position to answer that what would be the pattern of the questions in the examination. Okay. Hereby you will contact the team, and before the examination it would be given in the admit card and everything will be communicated beforehand too. We are the NPTL TAs of this particular, we are the PMRF TAs, okay, for this particular course. There are NPTL TAs. Their job is to create the lecture handouts for the professor to teach, and their job is to create the questions, objective questions, and their job is to answer the create the objective questions, subjective questions, and create the question papers and evaluate your assignments. There are separate NPTL TAs for them. They will be in a position to tell you that what would be the pattern of the examination. I am responsible for clearing your doubts. Okay. So I am the PMRF team. As part of my PMRF TA duty, I am performing, I am taking your lectures, I am solving your doubts. I am concerned with this particular information only. That is why. They contact them, they will be in a better position and they will be able to tell you what will be the pattern of the examination and how you can approach. Can you tell what will come in the exam from Python? Okay. See, solve the assignments. That is the master trick for getting good marks in the examination. Solve the assignment questions and be in touch with the NPTEL team. I am providing to you both the Python Colab notebooks as well as the assignment solved questions. Go through both of those. Okay. And what exactly will come that I am not in a position to tell you because I have not designed the question paper. Okay. They are designed that question paper. They will be in a position to tell you that what exactly will come from Python portion. Okay. Whatever the professor is trying to teach you in the offline lectures, in the recorded lectures, and whatever things you are seeing in the assignment. Okay. And these collab notebooks, they are more than sufficient for you for clearing this examination with good marks. Yes, collab notebook is enough for the examination as far as I am concerned. But the main concern is you are following through the uh, lecture videos also, which the professor has already recorded. You just try to follow those also. Go through the notes also, which are there in whatever he is teaching, and along with the solving of the assignments and these doubt solving session. These are more than enough for you to clear the examination. Okay. The relevant material I will provide to you. Okay. This is the end from my side. If you are having any doubts, feel free to ask. Okay. Otherwise, you can kindly leave. Do join the session next week, same time, same way. Okay. Yes. When we create a panda series from a dictionary and one of the specified indices doesn't exist, it returns NaN. What the empty type automatically changes from int to float 64 just because of NaN value? No, it will not automatically change. And what is happening internally in pandas? Please uh, write this entire question on this particular mail. Okay. Okay. Write this entire question and send it to me on this particular mail. And then I will reply to you with performing this particular thing in the Polar notebook. Okay. I will give you the written example. Okay. Thereby you will see that what internally is happening in the pandas and why from int to float 64 the direct data type it has changed. Okay. Not able to demonstrate here because I have to create that panda series. Okay. Then after creating, I will do this thing. Then thereby you will yourself be able to appreciate that what thing is happening inside the pandas. Okay. If you are not able to send, then I will do send me. Okay, this particular question on this particular mail. For clarification, I am myself attaching this particular question. Okay. I will provide the explanation in the coming weeks handout also. It might be a question for a lot of our friends also. Okay. So you all will get benefited. That is why I will provide an explanation to you all in the coming weeks lecture. Okay. So do keep your query till then. Okay. You also try to give me a mail to give or try to give this query in the mail. I'll reply to you. Okay. The explanation. For the benefit of all the students, I'll try to include the explanation because this is a very common query that how some data type internally it is changing. Okay. Yes, yes. How pandas is automatically aligning indexes. Mention all of your queries in the mail. I'll reply to you. I'll reply to you. I'm saving here for my own reference, but do mention all your queries because they are just originating because you are having a doubt in one particular concept. So I'll clarify, I'll create a notebook and then I'll try to clarify it to you how internally the data type is changing and all of those things. You mention it in the mail, okay? Any query regarding any question, any assignment, you can share to me in the mail. Here I am not providing to you the explanation. Why? Because I have to write down the code, then I have to comment some of the things. It will further on stretch the session. Okay. That is why I'm not providing here itself, but I will give you the written explanation. Okay. Within the mail. Okay. As well as for the benefit of the students, I will try to demonstrate. The dtab was changing in this notebook also and in the previous notebook also. But only you were observing. I admire it. Okay. Only you are keen enough to ask me, but rest of the students should also think about this. How the data internally it is changing. Okay. You try to run this notebook, multiple places you will observe the same thing. Okay. Yes. Why does pandas use numpy's NAN for missing values instead of allowing native integer null support by default? See, in different of the versions, in some of the earlier versions of the pandas library, ranging from I think 1.0.2 till that versions, it allowed us to this negative native integer with null support by default. It allowed, but as and slowly the library is getting updated. Okay, the instead of negative integers, okay, you are just going for NAM. Okay, why is it happening? Because pandas and sklearn and all those libraries, these are very commercial libraries. A lot of features are removed and lot of features are added just in order to facilitate the processing, fast processing speed. So some of the features it has degraded, it has upgraded, and a lot of uh, things are there. Why in particular we are providing updates so that most of the things can run through a much faster pace. That is the only thing, only explanation which I can give you. If you want to create your own version of that particular library, it is also possible. Okay. Download the VS Code, download the earlier pandas library inside it, and inside that particular folder, source folder, you try to provide your own version of pandas library. You can edit it any number of times. Same particular facility is there in C++, same particular facility is there in C Sharp. But most of the people, they are working on Panda, they are working on Python. That is why the libraries are updating very fast. Yeah. Just you don't have to do anything. You just go to the Pandas library there. By you just give a pull request. It will be updated. It will be you will be provided the access to your pull request. Okay, within seconds. And if you are tagging them on GitHub, if they find your particular update or your commit is useful, they will be updating that particular uh, uh, update in the next possible version of the library. Okay. What is the difference between none, nan, and pd.na in pandas series? When does each one appear? Do write it down in your email also only because I will demonstrate both of these three different none, nan, pd dot ne with example. Okay. Difference between none, nan, pd dot ne, all things I'll just give you. Okay, explanation to this particular question I have provided to you. Still, if any further explanation is required, I will try to provide you. Explaining you all these things. Okay, you just have to write few of the examples. Then only you will be in a position to get. These are your questions, and for the benefit, do join the next week's session. I will create the explanation in the website. Okay. Any more doubts are there, feel free to ask on this particular email ID. Okay. I'll send it here itself. Okay. Try to answer. Send you the answer. Okay. If you will mail me, I'll try to send you the answer. Otherwise, for the benefit of all the students, I will create an example for each and every particular case and in a separate notebook I will answer all of your doubts. Okay. Okay. Thank you so much for joining the session. Do join the session next week, same time, same link. Okay. And I'll take your leave. Okay. Thank you all for joining the session. Do join the session next week, same time, same link. Thank you all once again. Okay.